is actually the creator of Espruino. So yeah, it's going to be even more amazing, especially if Wi-Fi works.
Yes.
But the best bit is just going to do all the hard work. Let's get started. Right. So there's three things I always tell people that they need to know about Espruino before we do a demo. The first one is software. So Espruino is an open source JavaScript interpreter for microcontrollers. You could run it on any board that you want to board it to. The second thing is the hardware. There is actually the Espruino Board itself, which is tailor-made for running Espruino software, and it really shows Espruino's advantages of just great interactivity and battery life. And the third thing, and probably the most important, is that it's really, really easy to get started.
Okay, so this is the Espruino board, and it's there's just one microcontroller on it, which has like a software USB port that appears as a serial port. So you just take it and you plug it in, and it will appear as if it's a modem. So if I now swap over to, for instance, a command prompt, like any terminal application on any operating system will just work, and instantly you can kind of type in commands. I mean, you can't see very well on there. But as I'm typing characters, each character is being sent directly over to it, and then it's executed on the chip and the results returned. Now, you could program like this, but obviously it's much better to have kind of a purpose-made IDE for it. So we came up with this, which is a Chrome web app. So all you have to do is install it from the Chrome Web Store. If you've got Chrome web browser, that's enough. And when you install a web app, you can get access to a few extra things like the serial port. So this all works really nicely for things like schools. On the left-hand side here, we've got a terminal window, which if I just connect, you get exactly the same thing as before. There's a command history, so you can kind of see the command I typed in before, step back and execute it. And on the right-hand side, you've got code that you can type with a standard syntax highlighted editor that's got a bit of command completion in as well. So if I put this down so you can see it, and turn on the sort of presentation mode that makes life a little bit easier. So now you can just type in standard Arduino style commands like digital write maybe. If I can spell. And now that'll be executed, and obviously you see it light up. You can actually write functions as well, and define them, while everything's running. So if I do this, now if I call flash, obviously you'd expect the light will go on and off. But there's also like normal JavaScript stuff you'd have in a web browser. You've got set interval. So so I've got it flashing. But obviously you can, while this is running, you can still execute commands. In fact, you can still redefine the function. So because it's JavaScript and it's not typed, you can stick extra things in. So instead I can put an array in here of maybe the 3 LEDs. And maybe if instead of, so I just increment it. And now it's kind of outputting the binary number from L on all of the LEDs. And you can see the value of L as it goes up. In fact, you can even change it to something else to restart it. So yeah, this is one way of working. The other way of working is to define something on the right-hand side. Now I'll just swap over so that we can see something else. This is an old, it's a Nokia 5110 LCD, which is available just to buy from eBay various places for about $2 or something. If I plug this and I upload this code. When I upload this code, the web IDE will actually look online. It will find that there's a module written in JavaScript called PCD8544, and it will automatically load it into the board. So if I do this, it will actually write hello, and you can just about see it on there, although not very well. So what would help, because it's a bit dark, there's actually an LED backlight on pin A3. So if I just, there are various ways of setting outputs. You can use digital light, or you can, every pin is in fact an object which has got various things on it, like light. I think the logic's inverted actually. Yeah, there you go. So now hopefully you'll be able to see a little bit more of it. And you can see that the contrast isn't quite right, so when you're viewing it at an angle, maybe you can just call set contrast and try different things. So that's a lot better. Obviously the font size, we can just now step back to this side and just change the font. It's got vector fonts as well if you need them. And while we're here, let's turn the, oops. So now if I send the data over, hopefully we'll see something a bit bigger. Yep. So on board it's got a temperature sensor as well. So you can just simply say either get temperature, and it's way over room temperature at the moment because it's being powered by USB and it's sort of syncing about 30 milliamps. So it's just a little bit over. But you know, you get a pretty good idea from this. So what we might want to do is we might want to make a temperature display. Just to say that there's a line up there, which is purely because there's a draw line command in here, which I can get rid of. So now if I just copy this and make another function that will just output the temperature. So this is, again, standard JavaScript. So you've got built-in functionality like toFixed that will actually convert the number to a string with the number of digits that you ask it for. So now if we just call this with set interval, and because you can save stuff onto the chip so it'll load at startup. So we want to make sure that if we had saved the previous interval from the last time while I'm demoing it, that we clear it. So I'll just add this here and send it over. Okay, so now I've got the temperature. We might want to do a history graph as well. So we can knock that up quite easily. And we'll do it actually all in the interactive side here. So we define an array called history. We'll step back up to where we've got this function, and we'll just write in here the new temperature value. And maybe there are only 84 pixels in the screen, so you want to make sure that if we go past that, we take stuff off the end. So this isn't going to do anything except change the value of the history array. And you know, we can see every second new stuff gets added to it. So now, if we just start drawing. So for each calls this function for every element in the array. The first argument is going to be what we put in the array, and the next argument is going to be the index. Yeah, right. And now hopefully you can't quite make it out because it's right on top of the screen. So instead, we'll just add 30 to it to bring it down. And now you've got the temperature display, with a graph. And actually, we can just say save, and this will save it onto the flash on the chip itself. So now, if I take this off, I'll just unplug it and just plug it back to it instead. I've done this. Right. Okay. So we can just reconnect. And see what there was. I think it's a timing issue, but we'll leave that for now. If I just unplug USB, you've got a temperature sensor that's battery powered. That'll last for ages. Like, probably the biggest thing running it down now will be the LED behind the display. And over to you.
Okay.
Oh, is that mine? Yeah. So how do we do this? It's actually a purpose-built JavaScript interpreter, because you can't get something like V8 into the chip. I mean, the chip has, the one in here has 48K of RAM, and Node itself will allocate several megabytes in buffers just when it starts up. Node's very efficient, but it's designed for a computer that's got actually 1 million times more RAM, and probably 10 million times non-volatile storage. So it's all open source on GitHub now, all of it's C. Again, there's very little room available because it's targeting microcontrollers that may only have 8K of RAM. So you really can't afford anything else in there. And as you've seen, you can program it just with a simple serial port.
Just a bit of a background. So Espruino software has been around for a while, but it wasn't until last September that Gordon wanted to put together some hardware to really show off the board. So he ran a Kickstarter campaign, and that's how I first came to hear about it. And he was looking for just 20,000, and he sort of got to that in the first 4 days and went on to get 5 times what he was looking for, which resulted in over 4,000 boards being manufactured and going out into the world. And a bit about the board.
Yeah, so this is the actual hardware. You've got the microcontroller, which is obviously taking up most of the space. In fact, if we step down to this one, there's space for a Bluetooth module to be soldered in the back, so you can get kind of BLE support or just standard Bluetooth if you want it. On the other side, because there's a bit of space there, there's kind of a prototyping area where you can put in chips like motor drivers, extra memory, stuff like that. You've got a micro SD slot and a few LEDs, buttons, and there's loads and loads of I/O. I've tried to bring pretty much everything out. So you've got A to D converters, which will read voltages, D to A's, which will output a steady analog voltage, PWM, which is pulse width modulation, which will let you kind of fake an analog voltage by putting out a specially shaped square wave, and loads of communication interfaces as well. CAN bus is the one that I don't have a wrapper for. All the other ones, there actually is a wrapper for it. And it's kind of, it's tried to be similar to Arduino stuff so that you'll at least have a real clue what's going on when you come to it.
Do you want to answer Tim's?
Oh, sorry, yeah. Yeah, so on here, you see there are a few of them say 3.3, and those ones are the ones that aren't, but all the rest of them are. And in fact, while they will only output 3.3 volts, you can put them into an output pull-down mode. So you can then use one resistor to pull it up to 5 volts, and you can still get the full voltage swing on it if you need that. So it is, it can be compatible with Arduino shields and stuff with a few extra components.
Okay, so this slide is just to try and sort of show the differences between Arduino, Raspberry Pi, and Espruino. All the quick show of hands. Who here has an Arduino already? Yeah, and who's got the Raspberry Pi? Okay. Yeah, so you probably already know this, but if you start at the top and you've got the user software, and down you've got the hardware, the idea is what's between you, your software, and the hardware. And on the right here with Arduino, you write your code, something to flash a light, and then you compile it, and that gets compiled straight to object code, and that runs directly on the board. So in this case, it's bare metal. And that's good because you get a lot of control, but where it's not so good is that sometimes bare metal can be a pain, and that's a quote from our friends in Fab Lab in France. And when it comes to doing things like scheduling, sometimes you're a bit on your own, and you have to kind of manage things yourself, especially if they aren't libraries to do that for you. On the other extreme, on the far side, you've got the Raspberry Pi. There you might write your flashing lights in Python. And then between your software and the board itself, you've got the opposite extreme of Arduino. You've got this full stack of Linux and all that involves, as well as the Python interpreter. And you might have lots more stuff as well. So the Raspberry Pi is really, really powerful, and you can do a lot with it. But if you're just looking to have a few flashing lights with some sensors and some actuators, then sometimes it can be a bit overkill. And particularly when it comes to battery life, it will run down your battery very quickly. So with that, Espruino is trying to sit in the middle of saying, what's the minimum software we can have that's really useful to the user, but it doesn't actually eat away at your battery life. And that's where the Espruino JavaScript interpreter comes in. It gives you that control, so you can control things on the board directly, but it has things like the ability to schedule and set interval, and knowing when to go to sleep as well, which makes it really good for battery life. And let's see a bit more on that.
Yeah, so one of the reasons it's so good with battery life is that because you're getting the interpreter to do all the scheduling for you, you're writing small tasks, small JavaScript functions that get executed one after the other. It's aware of things like how much time it's got until it next wakes up, or which input pins it has to actually listen to wake itself up. So it can very, very easily go into very low power sleep states. And it's not helped that on something like an Arduino, you can reach these very low power points by kind of explicitly writing sleep instructions. But the standard Arduino boards are not designed for that at all, so they'll be drawing pretty much 4 milliamps constantly just because of the voltage regulator. So the weird thing is you end up with Raspberry Pi that will be about 100 milliamps absolute minimum. Then you've got Arduino that will be maybe 20, 30 milliamps. And then Espruino, it's still 20, 30 when it's running, but when it's asleep, it'll be drawing about 30 microamps. So, I mean, and it just shows that you have a massive difference as long as you're doing something that's only waking up every few seconds. So, I mean, one of the ways that you can get this huge performance improvement over something like a Raspberry Pi is that you have a lot less RAM, you have way less transistors. And the same applies for Arduino as well. But the interpreter it was originally designed for 8K of RAM. We've put more in the Espruino board. And that's what 8K of RAM looks like compared to the website's 16-pixel favorite icon. And if you tried to compare that to the icon on the home screen of your Retina iPhone, suddenly it looks absolutely minuscule. And that's got to hold all the interpreter state, it's got to hold any input-output buffers, it's got to hold your code and the data your code uses. So it's kind of quite difficult trying to cram everything in there.
Okay, yeah, so since the Kickstarter, there's been lots of support for various devices, and if you go onto the Espruino website, you'll find code which lets you connect to any one of these devices, and sort of more comes on all the time, because it also has a very active community of people who like to tinker and to just like to play around with things, and a lot of the projects you find on the forums are related to things like home automation. My particular interest has been Espruino for education. I collaborate with a lot of educators, and one of the things I was quite interested in doing was taking the kids who go to these tech camps and they're already learning JavaScript for programming, the web, and we're saying, well, can we take those skills and introduce them to hardware and get them playing around with hardware? And actually, in addition to that, we've got a project next year with the local school where we're targeting a younger age group, and we're going to get them using, so these are kids who can't program, don't necessarily have an interest in programming, but we're going to present it as a full application of they're building their own little night light, which is connected to a motion sensor, and they'll do it using the blocks, which you can see. Can you show the blocks?
Live? Or?
No, the Scratch-like interface. Did you show that one? Did you do
I didn't do demo of it, no.
Can you show that? Sorry? No, it's Blockly. So yeah, there's a way to program it just by using blocks. And so we want to use that for people who haven't programmed, and they can just build up their programs like that and really focus on an end application of something practical and sort of see programming as a means to an end rather than, so try to bring in this group who wouldn't want to program just for the sake of it.
Okay. That's odd. Oh yeah, all the slides have got messed up. So there's also a new Kickstarter which was just started last week, which is, it's a slightly different chip because technology's improved a bit since I did that. So it's much smaller. This is the size of a USB key. So it should open up a whole load of new things you can do with it. I mean, almost well using it like a plug just to interface electronics to your computer, because it is a serial device. You can just kind of echo commands like digital write or whatever directly to it, or you can write code and then just literally copy what comes down the serial port into a file.
And that one, that's already been funded after sort of 4 days on, so if you want to get one, it's definitely happening.
Yes, yeah.
Yep.
Are you doing that? Okay, yeah, so, I mean, the Web IDE it's locked to Chrome because Chrome is the only thing that allows us to access the serial port from HTML and JavaScript. And there are plenty of cloud tools that run totally in the cloud. You've got Embed, and they do the compilation on a server somewhere, and they send you a file. And instead of appearing as a USB communications port, it appears as a USB mass storage device, and you can just save your file directly onto it. And that works really nicely, but you don't have any debugging, because it's a very kind of one-way thing. You write your code onto it, and if it doesn't work, you have no idea why. You can't query the values of variables or anything. Electric Imp works using an actual connection to the internet. It's got Wi-Fi on board. Same with Spark Core. And then you've got Orion, which is a really nice development environment. It's really getting there, but it doesn't yet have a way to program anything.
Yeah. So at EclipseCon France, one of the things I wanted to do was see if we could use Orion with Espruino, because Orion's a good cloud environment for developing JavaScript. And so there's two sort of approaches of putting Orion inside Espruino, and that was simple enough to do by just having the Orion editor embedded within Espruino. But then on the other side, we're like, oh, well, can I get Espruino inside Orion so I could write my programs in Orion and then download that to the board? Can you go to the next one? So this was my vision, that new users would start off with just interactive commands, and then they'd graduate to using the single editor or the block editor. And then when they got really advanced, they would use Orion to do multiple files, projects, and things like that. But there was only one problem, that Orion is all up in the cloud and everything runs in frames, and I couldn't actually figure out how to get it talking to a real piece of hardware on my desktop. And everything in the frames is all security based, so you can't actually access the hardware. So we talked to the Orion folks and to a few of the Eclipse folks and said, well, there must be a way to do this, and how can we get around that? And brought Gordon in, and he had a few ideas.
Yeah, so the idea really was to use a standard web browser, standard Orion, and just try and implement it as a plugin. And it turns out that because of the iframe security, it's quite difficult to find any way to talk out of Orion. But you can write things into cookies, and you can use that with another window which is outside of an iframe to get the data out. So we've got a little plugin which is literally 10 lines of code that does that. You just click download to Espruino and it copies the data into a cookie. So now you've got it into a cookie, how do you actually get it out? You know, we could put some kind of internet connection onto the board, but you kind of lose a lot of the really nice things about the board, which is the power consumption, because you know wireless networks do take up a lot of power. We could do the USB mass storage again, or we could try and come up with some browser-specific plugin, but then you lose a lot of the compatibility. You know, we'd have to do one for Mac, one for Linux, one for Windows, and then you're still completely stuck on something like iOS. So that leaves one other thing, which is the audio port. Pretty much, you know, any web page can make sound with the web audio. It can record sound as well, and it's actually really well suited for going down a serial port because you've got really accurate control of the timing. So up in the top left, you've got the kind of input voltage range expected by the controller itself. And it turns out that you only have to move the voltage up and down by about 0.6 volt to actually get a 1 or a 0 registered. And you've got 1 volt peak to peak coming out of the audio. So, you know, trying to fake that wave on the right is relatively easy. And you don't need very much in the way of components. So this circuit here, it relies on the fact that there's one built-in resistor inside the microcontroller itself. But on the whole, you've got 3 resistors and 1 capacitor, and you don't even need the capacitor on most computers. It's only for the few computers that have direct coupling. So, to the demo. Now, this is a bit iffy because I updated Ubuntu recently, actually just tonight, and it appears to have been very unhappy with me. So, we'll see if it works. The code here is all on GitHub. It's actually hosted on GitHub as well. So what I've done is I've got the plugin, which I'll load up Orion in a second, and put that in. But we do have a special window here, which is making lots of nasty noise, and it's actually listening to the microphone at the moment and trying to interpret that as serial data, which is producing loads of random stuff. So I have here an Espruino board with 2 plugs, and all of the passive components are actually just hidden inside the plugs. So it's quite easy. So if I take this and plug it in.
And what I really like about this is that if we're talking about going into schools, we don't even have to get involved with the IT department in terms of installing things or getting past firewalls to do the programming. We just use the audio jack.
I'll just check the sound settings are right. So if I plug this in, so that loading from Flash and the new line, that came directly from the board and was just interpreted. So I hope, let's see if I type something. No, it hasn't worked. Okay. I've realised there's a fudge for this. Hope this works. Okay, so now it actually is working. You send data out, and like before, but it's all done by the audio jack, so this will work on anything. So if I now go to Orion, it's where we have to hope the internet works properly. Yeah, absolutely. The only difference is that, I mean, because the Arduino, a lot of them are running off 5 volts, you may need a bigger voltage swing, which may make it less reliable, but a lot of Arduinos now are 3.3. And the Espruino board has an internal pull-up resistor, so you would need 1 extra component to make it work on an Arduino. but it's all stuff that, yeah, that should work fine. So I have some code here that should calculate the amount of bottom output it, and I hope, if I swap back to here, now again, because of this OS update, I think it seems to be doing a lot of buffering up, so it's going to be quite a while before it goes and, okay. Well, it's half working. You can see bits of Madrigal up there. But it was working perfectly on every computer I tried it on before an hour ago. But such is the curse of doing stuff live.
If it all works, you're not pushing it hard enough, so there you go.
The other nice thing we have here is, as well as Orion, and this was a really quick hack, but the same Google Blockly, because it's all an online thing, it can work in exactly the same way. So you can see as far as education goes, you could actually offer a website that runs on a tablet that has a drag and drop interface that works on just really, really cheap, easy to use hardware. Right.
Okay, yeah, no, just to, in summary, Espruino, it gives you the best of having a high-level language but low-level control for doing your hardware, and really the big benefit as well is just having good battery life for just things that can last in your home or wherever you set them up. And yeah, for us it's just fast and fun development for real devices.
Okay, that's it.
Thanks, and any questions?
So far, what I've seen is based on the Espruino hardware. Like for example, how far can you bring it? For example, the Arduino, I can use the Arduino, I can plug out the ML chip. Somewhere else I use the watchdog for saving battery or something like that. With the Espruino, is there something I can do like that, or is it just meant for education?
Sorry, can you use Espruino on other devices, you mean? Or?
Either use, or like in this case, it's a SMD chip, it's folded. I cannot use it, for example, prototyping that and bring it along further to real cases or something.
No, well, you just have the whole thing. You can use it exactly the same as with Arduino. Yeah, you can put it on.
Or you use it as is, the whole board.
Yeah, you could use it as is, the software just on that board, and put that into whatever your application is, or you could run the software on, you could set up the interpreter on your own board or your own device and use that.
I mean, it's all open source, and it's actually already ported to a lot of the STM discovery boards, so you can just get it and run it on that. The only thing is, like, put a lot of effort into documentation and stuff, and the documentation, all the pin names, all of that stuff are just expecting you using the board. Other questions?
Question is, how much does it cost?
The board is £25 at the moment. The one on the Kickstarter is £15 for the smaller board, but after the Kickstarter that will probably go up because distributors take their cut and stuff as well. Yeah.
So you went to the web to make a controller. Is this targeting the educationists or something more in this field where you don't really care about having a web to make a controller, set up the development? So who are your targets then? Whether it's make it portable for the learners?
Okay, so is the question, who do we have in mind when we talk about using the cloud as the IDE?
So you went to the Chrome extension,
Yep.
make it portable web so that you don't have to set up.
Yep.
So I think initially it's just tinkering and possibly education, but I can see that the way of communicating could actually be useful in other ways. For instance, you may have some relatively cheap hardware and you want someone to be able to walk around and just read what's in it off. And that's something that actually, if it's just like a headphone jack or something like that, that's the cost that's needed, and a few passes which were effectively free, it could be a really neat way of working, rather than having to add wireless and potentially, if you're working around and you've got to, I don't know, pair wirelessly with 100 different devices each time, just plugging in, pressing a button on a website could be really cool.
I think having tools in the cloud is the direction lots of things are going. So whether you talk education or just people using it, it's just making it a low barrier of entry for people to adopt it.
Yeah. That's a hard one to quantify.
What was the question?
Oh, so how much power does the interpreter use, I guess, compared to running native code? Yeah. In terms of actual raw speed, if you were to try and toggle an I/O pin on and off with a loop, I think you get about 3.5 kilohertz at the moment. I mean, that'll improve a little bit. But I mean, obviously, if you were writing C code for that, you'd probably be about 1,000 times faster. So it does make a big difference. The saving in power comes from just the fact that it's a lot easier to save power. So if you were really going for it, you'd write native code. But actually, for 90% of cases, it's more than good enough. Any other questions?
Okay, thank you very much.
Thanks.